In this video, we're going to be talking about doing horizontal transformations with two parent functions, the sine of theta and the cosine of theta. So before we begin, let's just go ahead and review the graphs of the sine and the cosine and their parent function tables. So both the sine and the cosine are periodic or cyclic, which means that they have these waves that they just keep repeating forever and ever to the left and the right. If you look at the sine on the left here, the parent table beneath it is going to be filled in with 0, 1, 0, -1, and 0. And you can gather these y values either from the parent graph that I have graphed above, or when we first built this, we used the unit circle. And then with the cosine, we have a similar shape, and the parent function table is also similar. -1, 0. Sorry, 1, 0, -1, 0, 1. So let's first just go ahead and review a little bit about vertical transformations. So here you'll see the general form of an equation for graphing sine or cosine. And you could switch out this sine right here. Let me do this in blue. You could switch out that sine for a cosine, and it would be the same thing. So if you have a constant in front of the sine, that's going to change your amplitude. So that kind of stretches your graph up and down, and that would be a vertical stretch. Adding something to the end, like this plus d at the end, that shifts the graph up and down, so we call it a vertical shift. Today we're going to talk about what happens with this b and this c value. So let's actually start by talking about the c value. So that c value, which is what you're subtracting from the theta, and the c value is always going to be in parentheses, this moves it left and right. Okay. And this is where it's going to get a little bit confusing, because as we shift left and right, it's the opposite direction of what you would guess. So negatives, if you're subtracting like 3, that's going to move it to the right. And positive, a positive c value is going to move it to the left. So we call this in these graphs of sine and cosine, we call this a phase shift. So it basically just means that we're shifting the whole graph just a little bit to the right or left. So when we ask for the phase shift, we're asking for what is that c value. So let's go ahead and fill that in up here. Now let's talk about the b. So before we even jump into the b, I want to jump back to our parent functions and talk about what a period is when it comes to sine and cosine. So like we talked about at the beginning, these graphs just keep repeating themselves over and over again. They're cyclic, and we often call them periodic. So one period just means that you complete one full cycle of the graph. So with sine, you go up, you go down, and you go back to where you started. And then you would start a new cycle of the graph by going up and down and go back to where you started. So the period is basically the length or the distance that it takes to complete a full cycle. So in this case, the period is from 0 to 2 pi. So we would say the period is 2 pi. And that's the same thing with the cosine. The cosine is going to complete a cycle in 2 pi as well. So if you don't change the period, then the period is going to be 2 pi. But there is a way to change it. So say we want these, like say we want the sine graph to complete a full cycle in pi, in just pi. That would mean that I want my graph to do a whole entire cycle, but I want it to complete that cycle by the time it hits pi instead of 2 pi. So in this case, my blue graph would have a period of pi. Okay. So let's talk about how we would change our equation to create a different period. So this b value is going to change the period. So to find the period, you do 2 pi divided by your b value. Okay. So usually our b value is 1, so it's just like 2 pi over 1 is equal to 2 pi. If you wanted your period to be just pi, then you would want your b value to be 2, because then when you do 2 pi divided by 2, you just get pi. Okay. So if we look at this, actually it's coming out in a second. Let's just get on this definition of period. So period is from any point to the next corresponding point. And corresponding just kind of means matching. And this B up here is going to affect the period change, the period. So let's just look at this. I'm going to zoom in on this picture right here because I think it's a great example of kind of summarizing everything that we've talked about with horizontal and vertical transformations. So in the yellow over here, we see that phase shift, which shifts it left and right. In this nice aqua teal color, we see the definition of period. So you take any point, figure out how long the graph takes to get back to that point. That is a period. The vertical shift is how far up and down you're shifting the midline of your graph. And then the amplitude is how far up and down you go from the middle of your graph. Okay. So let's go ahead and do some practice. I just want us to look at how we would graph some of these transformations. Okay. And in this section, we're just going to be focusing on horizontal transformations. There's not, if I remember correctly, I didn't put a mix of vertical transformations. We will mix them together in the next video and in the next lesson. But for now, we're just looking at what happens when we do a phase shift or when we change the period. So my phase shift, remember, is affected by the number that I'm adding or subtracting to the theta. So since I'm adding pi, that means that I'm going to move left. I'm just going to put an L for left. Pi. Okay. My b value, which is the value in front of my theta, is just 1. So my period is 2 pi divided by b. So 2 pi over 1, which is just 2 pi. So let's go ahead and look at what this parent function table would look like. So first, these bottom two lines are just going to be the original parent function. Okay. So I'm just going to go ahead. We're doing the sine of x, so I know I'm going to go by increments of pi halves. And then I've got these y values down here. So since all we're dealing with is horizontal shifts, so we're shifting left and right, and maybe we're like squishing it horizontally, we're actually not going to change the y values. So these y values that I just wrote down are going to be the final y values that I graph in my graph below. What I am going to do is I'm going to be changing my theta values. Remember, my theta is related to my x. And the way I'm going to change them is I'm going to look at the phase shift. So in this case, the phase shift says I'm moving left pi, which means that I need to subtract pi from all of my theta values. So that means that my 0 is going to be negative pi. My pi halves is going to be negative pi halves. My pi is just going to be 0. My 3 pi halves is going to be pi halves. And then my 2 pi is just going to be pi. So now I've transformed my x values. I am just going to graph the two highlighted rows. So the top row that has the pi's in it, that's going to be my x values. And then the bottom line, the 0, 1, 0, negative 1, and 0, those are my y values. So at the point negative pi, my y value is 0. At negative pi halves, so right in the middle of that, my y value is 1. At 0, I'm still at 0, which is nice. At pi halves, I'm at negative 1. And then at pi, I'm at 0. Okay. So if I connect these dots, you'll see that nice sine wave that I created. Okay. If you compare this to your parent function, it is shifted over to the left pi. And remember, we always want to graph at least 2 full cycles or 2 full periods. So I'm just going to kind of mimic the pattern here to get at least 1 more period graphed. Okay. And if you want to graph more, that's totally great. It's actually probably a little bit better. But we want to make sure that we at least show 2 complete periods of this graph. Okay, let's look at another one. So in number 2, I'm graphing the cosine of theta minus pi fourths. So my phase shift is at negative pi fourths. Since I'm subtracting, I'm going to move to the right. So it's the right pi over 4. My b value is the number in front of my theta, which is just 1. My period is always 2 pi divided by my b value, so it's just 2 pi. So let's go ahead and get down my parent function values for the cosine. And make sure when you're doing these that you are really careful to use the cosine or the sine depending on what the problem is. Okay. And since I'm shifting to the right pi fourths, it means that I'm going to add pi fourths to all of these values. Okay. So 0 plus pi fourths is going to be pi over 4. Let's take a look at what it would be to add pi halves plus pi fourths. So I know that sometimes having the fractions and the pi is a little confusing. But what I'm trying to do is I'm trying to add pi halves and pi fourths together. In order to do that, I need to have a common denominator. So I'm going to change this pi over 2 by multiplying the top and the bottom by 2. So I get 2 pi over 4 plus pi over 4. Then I just, oh, that is a 3, not a 4. Sorry. Once I have a common denominator, then I keep the same denominator and I just add the numerators to get 3 pi over 4. So that would be my new x value right here. And you're going to do a similar thing with all the rest of these. Okay, so if you need to hit pause and take some extra time to practice adding these values, that's totally fine. So I'm just adding pi fourths to all of these. 3 pi over 4 would be 6 pi over 4, so I'm going to get 7 pi over 4, and then 9 pi over 4. Okay. So now I'm going to graph this bottom line and this top line. And I'm kind of just ignoring that middle one. So that middle line with just the original thetas, that was just kind of a helping hand to get me started. So when x is pi fourths, which lies right between 0 and pi halves, my cosine is 1. When x is 3 pi over 4, which is right between pi halves and pi, my function value is 0. At 5 pi over 4, I'm down at -1. And then at 7 pi over 4, I am at 0. And then this next one, 9 pi over 4, is actually off the graph a little bit. Okay. So let's go ahead and connect those dots. Those points, rather, is what I should call them. Okay, and that's what my cosine graph is going to look like. I'm going to go ahead and mimic the same thing on this other side so that we make sure we have at least one complete cycle. Sorry, at least 2 complete cycles. It should look something like this. So if you compare this to your original cosine graph would have points that were exactly pi fourths to the left here. So those 3 red points would be points on the original parent function. Oops. Okay, we are going to do these next ones. Okay, so with number 3, we're graphing cosine of 2 theta. So my phase shift would be the number that I'm adding or subtracting from the theta. In this case, I don't have any. So there's no phase shift, so I'm not moving left or right. My b value is the number right in front of the theta, so it's 2. And to find my period, I do 2 pi divided by 2, which is just pi. Okay, so let's go ahead and fill in our parent functions here, our parent function table. And I'm doing cosine, so make sure I grab the right parent function values. Now again, we're not changing any of the y values because changing the phase shift in the period is going to change what's happening horizontally with the graph, but it doesn't change anything about moving the graph up or down or anything. So the y values are going to remain the same. So to figure out what my new theta values are going to be, I'm going to use the 2, that's my b value. And what I'm going to do is I am going to divide all of my x values by 2. So 0 divided by 2 is just 2. Let's take a look at what pi halves divided by 2 is going to be. Okay, pi halves divided by 2, what I would do is think about this as pi halves times 1/2. It's kind of like 2 over 1 multiplied by the reciprocal. And it just turns into pi over 4. Okay. So pi over 4 would be that value. I definitely did this first one wrong. 0 divided by 2 is 0. I don't know why I wrote 2 down. Pi divided by 2 is pi halves. 3 pi over 2 divided by 2 would be 3 pi over 4. And then 2 pi divided by 2 is pi. One thing you'll notice is that whatever your period is, that should be your last number in this table, if you're doing tables the way that I am. So now let's go ahead and graph this. I have a point at 0, 0. Nope. I have a point, I was looking at the wrong lines. This is where it's important to make sure you're graphing the right lines. I need to be graphing the top line is my x values, the bottom line is my y values. I have a point at 0, 1, a point at pi fourths, 0, pi halves, -1, 3 pi fourths, 0, and then pi 1. Okay. Let's just go ahead and look at just this first cycle and make sure that it seems to match the transformations that we said it should have. So we said that the period should be pi, which means I should get through a full cycle in pi. And if you look down here, that is what happened. It took me from x equals 0 to x equals pi to complete a full cycle. So I'm going to go ahead and get another cycle of points plotted so that I can graph at least 2 complete periods here. And I could obviously keep going to the left as well. All right, let's take a look at number 4. So my phase shift here is none because I'm not adding or subtracting anything from the theta. My b is 1/4. So think about the fact that since I'm dividing theta by 4, it's the same thing as multiplying by 1 over 4. So my period is 2 pi over 1/4. And here I'm going to think about dividing by 1/4 is the same thing as multiplying by its reciprocal, which is 4 over 1. So my period is going to be 8 pi. Okay. So let's go ahead and fill in my parent function values, and then we'll talk about how big this period is going to be and what we're going to do with it. So remember that as I'm changing my period, I'm going to divide by 1/4, or in this case, that's the same as multiplying by 4. So I'm going to multiply all of my theta values by 4. So 4 times 0 is 0. 4 times pi halves is going to be 2 pi halves. 4 times pi is 4 pi. 4 times 3 pi over 2 is 6 pi. And then 4 times 2 pi is 8 pi. Okay. So now let's go ahead and jump down and start graphing some of these points. And I think we're actually going to run out of space based on the graph that I provided us. So I have a point at 0, 0. I have a point at 2 pi 1. And then a point at 4 pi 0. And then I have all those other points at 6 pi and 8 pi, and I actually don't have room to graph them. Okay. So this actually only gets me half of a period, which is not ideal. So what we've got to do is come onto the left side of the graph and draw the rest of the period. Okay. So if you look, I'm basically getting to one of my key points every 2 pi. So if I go 2 pi to the left, I should end up down here at -1. And then if I go 2 pi further, I should end up back at 0. So your graph is going to look something like this. Now, based on the period and the shape of this graph, I only got to and the size of this graph. I only graphed one period, and that's okay. If you only have space on your graph, if I've only given you enough space to graph 1 or 1.5 periods, that's fine. Ideally, we would graph 2, but if it's not possible, that's okay too. One thing I did want to talk about before we move on is just going back and reviewing this multiplying by 4 and how I did that for each of the values. So like, let's say I was doing pi halves and I was multiplying by 4. I would think about that as 4 over 1. I multiply the numerators together, so 4 pi over 2. And then to simplify this fraction, I just divided the top and the bottom by 2 to get 2 pi over 4. Sorry, to get 2 pi over 1, which is just 2 pi. So that's just the way that I think about multiplying by 4 when I'm dealing with pi. Okay, so we've looked at some phase shifts, we looked at some period changes. Now let's do both in the same exact problem. So the phase shift here is the number that I'm subtracting from the theta. So I'm going to be moving right pi. My b value is that number right in front of the theta. So it's 2. So my period is 2 pi over 2, which is pi. So I'm going to go ahead and fill in my parent function table really fast, and then we'll talk about how to get my new x values for this graph. So I know that if I'm doing a phase shift right pi, I'm going to need to add pi to my values. I also know that since I am changing the period to be pi, I have to divide all my values by 2. So what I'm going to do is I am going to divide by 2 and then add pi. Okay, so you might need some scratch work for this actually. So first I'm going to do, I'll just kind of work through I'll show you the work for both of these. So first I'm going to do 0 divided by 2. Actually, I'll do it on top because that kind of matches. I would do 0 divided by 2, which is just equal to 0. Then I'm going to do 0 plus pi to get that pi value. So I'm going to do the same thing for the next one. I'm going to take pi halves. I'm going to divide it by 2, which is going to turn into pi fourths. Then I'm going to do pi fourths plus pi, which is going to turn into, let me zoom in on this so you guys can actually see it, 5 pi over 4. Because pi is 4 pi over 4, so that becomes 5 pi over 4. And you might need to show even more work than this. You might need a piece of scratch paper for this. So then we're going to do pi, we're going to divide it by 2, so just get pi halves. Pi halves plus pi is going to be 3 pi halves. Three pi over 2 divided by 2 is 3 pi over 4. 3 pi over 4 plus pi is 7 pi over 4. And then my last one, I have 2 pi divided by 2, which is equal to pi. Then I just need to add pi. I'll get 2 pi. So that 2 pi actually didn't change. Okay. So again, this work that I just barely did at the top, that might be work that's going to take you a lot longer than what I did. It probably will. And you're probably going to need to get out a piece of scratch paper, or hopefully I provided enough space in the assignments. Down here, you could have worked it out down here at the bottom too. So let's graph this then. So I have created a really bad scale on this graph, I'm realizing. I'm going to change these really fast. Instead of pi fourth increments, I'm going to change them to pi half increments. So this is going to be pi halves, pi, 3 pi halves, and then 2 pi. And then over here I'll do the same thing. This is going to be pi over 2, regular pi, and then pi over 2. Okay. The reason I did that is because I just want these to be able to fit on the graph the right way. Ideally, I've created the right scales for you on your homework, so you don't need to worry about doing this. So at pi, I have a y value of 0. At 5 pi fourths, that's going to be right in between pi and 3 pi halves. That y value is going to be 1. At 3 pi halves, I should be back to 0. At 7 pi over 4, I should be down at -1. Then at 2 pi, I should be back to 0. So let's go ahead and sketch out that graph. I should get a full sine wave from that. And then I'm going to go ahead and mimic these points, kind of just copy them over to create another graph, or another period of the same graph, rather. It'll look something like this. That's what happens when you take the sine, you shift it to the right, pi, and then you change the period. It's from 2 pi just to regular pi, just to 1 pi. Okay, I would recommend hitting pause here and trying number 6 on your own. Okay, you'll probably get stuck at times, so hit pause, come back to this when you need to, but I would recommend trying it on your own for a little bit. So my phase shift is, again, the number that I'm adding or subtracting to the theta. So I'm moving to the left pi thirds. Okay. My b value is 3, which means that my period is 2 pi over 3. So I'm going to fill in my parent function table. -1, 0, -1, 0, 1. Okay. So I'm actually going to kind of do my work a little bit more extensively below on this one. So I need to first divide all my theta values by 3, and then I need to subtract pi over 3. Okay, because that's my phase shift. So I'm just going to go ahead and work through each of these. So my first theta value is 0. So I'm basically just taking these values from my theta row, and I'm going to perform these transformations. So first, I'm going to take 0. I'm going to divide 0 by 3 to just get 0. Then I'm going to take 0 and subtract pi thirds, and I'm just going to get negative pi thirds. So that is my new x value in this first column. Okay, so that's the first one. I'm going to do the same thing with pi over 2. So I'm going to take pi over 2. I'm going to start by dividing it by 3. So one shortcut is if you're ever dividing by 3 and you have a fraction, or dividing by any numbers, you can just multiply the denominators together. So I get pi sixths. Then I'm going to take pi sixths, and I'm going to subtract pi over 3. In order to do that, I have to find a common denominator. So I'm going to change this pi thirds to 2 pi over 6. So I get pi over 6 minus 2 pi over 6 is equal to negative pi over 6. So that is what happens after I perform the transformations on pi halves. Okay, let's do the next one. So I'm going to take pi. That's my original value. I'm going to start by dividing it by 3. Then I'm going to take pi thirds and subtract pi thirds. Well, pi thirds minus pi thirds is just going to be 0. So that's my new x value there. Okay. 3 pi over 2. Let's do 3 pi over 2. So if I take 3 pi over 2, I'll divide it by 3, which turns into 3 pi over 6. Then I need to take the 3 pi over 6 and subtract pi thirds. And again, I need to have a common denominator, so I am going to change those thirds into sixths to get 3 pi over 6 minus 2 pi over 6, which is equal to 1 pi over 6. So that is my new x value here. And then my last one is that I need to convert 2 pi. So I have 2 pi. Start by dividing it by 3. I get 2 pi thirds. Then I'm going to take 2 pi thirds and subtract pi thirds. And they already have a common denominator, which is nice. So I just subtract the numerators, and I get pi thirds. Okay. So it took some work. It took a lot of work, actually. But we were able to fill out that entire table that we needed. Okay, that entire row of the table. Now we just need to graph these. So maybe it's hard for us to see thirds or sixths on the graph. So let's just talk really fast about how to see those. So let me switch to blue. I have this length right here, which I know is pi. Pi is divided into 3 chunks, so each of these dashes is going to be pi thirds. So if you want to look at like pi sixths would be right in between, like these. If you were to divide each of the dashes in half, that would become a pi sixth measurement. Okay. So let's go ahead and graph the points that we have. So I have a point at negative pi thirds, 1. I have a point at negative pi sixths, 0. So negative pi sixths, remember, falls right in between your 2 tick marks. I have a point at 0, negative 1. I have a point at pi sixths, 0. And then I have a point at pi thirds, 1. Okay. So this is a super narrow graph here, which is good. The period is 2 pi over 3. That's a pretty small period. So we should get kind of a pretty narrow and smushed looking graph. I'm going to go ahead and mimic the points that I just barely did in the last cycle. So I can graph another period of this. Did I do that right? Make sure I got all those values correctly. And that is what your graph should look like. Okay. So the key with this is just take your time, do the work, work out these fractions like I did here, get out some scratch paper, find a blank sheet of paper somewhere in your notes, but make sure you're taking the time to make those tables accurate.